The echoes of the stars. Why Oumuamua still haunts our understanding of the cosmos. Imagine a moment when the vast, indifferent machinery of the universe pauses just for a heartbeat and whispers a secret directly to us. Not through thunderous collisions of galaxies or the fiery birth of stars, but through something small, fleeting, and utterly alien. A visitor from beyond our solar system, tumbling into view like a forgotten message in a bottle. This isn't science fiction, it's the story of Oumuamua, the first confirmed interstellar object to grace our skies, discovered back in October 2017. And as we stand here in late 2025, with humanity's eyes turning once again to the stars amid new discoveries and lingering mysteries, the question burns brighter than ever. What if this wasn't just a rock from another star system, but a clue to something far more profound? In this deep dive, we'll unravel the enigma piece by piece, from its bizarre arrival to the cutting-edge data that's reshaping astronomy today. Stick with me, because by the end, you might just see the night sky differently, wondering what other secrets are out there, waiting to be decoded. There are moments in astronomy when everything you thought you understood about the universe is quietly rewritten. Not by a dramatic announcement from mission control, not by NASA's polished live streams beaming across the globe, not by a sudden alert that stops the world in its tracks, but by a handful of unassuming images released without fanfare from a spacecraft quietly orbiting a dusty red world millions of miles away. That sense of quiet revolution is exactly what gripped the scientific community just weeks ago, as we navigated the ripples of a partial U.S. government shutdown that began on October 1st, 2025. With approximately 15,000 NASA employees furloughed and non-essential operations grinding to a halt, sparing only critical assets like the International Space Station, ongoing satellite missions, and the Artemis lunar program, the agency's release of high-resolution images from various probes was delayed by critical days. The world waited, telescopes trained on the void, for those pixels to drop. But in a twist that no one saw coming, it wasn't NASA that broke the silence, it was China. While anxious eyes on Earth scanned for updates, the Tianwen-1 orbiter, China's groundbreaking Mars mission, launched in July 2020, and now a veteran of orbital surveys, rover deployments, in-surface audio recordings, did something extraordinary. Originally designed not for deep space hunts, but for mapping Mars's magnetosphere, ionosphere, topography, and subsurface ice with its suite of 13 scientific payloads, including high-resolution cameras and spectrometers, Tianwen-1's medium-resolution camera was cleverly repurposed. Engineers adjusted its exposure and orientation, pointing it toward a faint, enigmatic speck lingering far beyond Mars's orbit, a green-tinged wanderer that had been the subject of hushed speculation for months. When the images beamed back to Earth, transmitted via the orbiter's relay systems that have already supported the Zhurong rover's 90-Sol explorations, they didn't just echo the whispers from NASA, the European Space Agency, ESA, or independent ground-based observatories. They shouted confirmation, they validated the anomalies. They made the unspoken fear among scientists impossible to ignore any longer. The strangeness of Oumuamua isn't a glitch in our instruments. It's real, intrinsic, and now etched in data from two worlds. The object's signature green glow, its eerie jets of material, its improbable stability tumbling through the void, its sunward plume defying solar winds, its rhythmic pulses like a distant drumbeat, features that had Western astronomers scratching their heads since 2017, were all captured with crystalline clarity from 30 million kilometers away. Tianwen-1, orbiting in its polar elliptical path, 265 kilometers by 12,000 kilometers, for over 4 years now, provided a vantage point no Earth-bound telescope could match. Another planet's atmosphere, another spacecraft's sensors, another nation's unfiltered analysis. Whatever Oumuamua is, be it a frozen relic from a shattered exoplanet or something that challenges our very definitions of natural, China has thrust the evidence into humanity's collective grasp. No embargoes, no delays, just raw, shared truth. And tonight, as we sift through these revelations in the wake of the shutdown's resolution on November 12th, 2025, via a continuing resolution that restored NASA's full operations, we're going to dissect it all, image by image, anomaly by anomaly, until the mystery coils around you like the tail of a comet you can't look away from. Because if we don't chase these questions now, with Oumuamua fading ever farther into the interstellar dark, we might miss the next visitor and the answers it carries. When Tianwen-1's images hit the wires through China Daily and Xinhua on November 15th, 2025, barely 3 days after NASA's furlough lift, the global scientific community didn't just pause, it froze in collective awe. Planetary scientists, astrobiologists, and orbital dynamicists refreshed their feeds, hearts pounding, as the first processed frames loaded. There it was, unmistakable, elongated nucleus glowing with a green-blue hue like a shard of cosmic emerald slicing through the black. Encircling it, a narrow reflective band shimmered faintly, while a subtle ion tail curved, not away from the sun, as every textbook comet should, but gently toward it, as if drawn by an invisible hand. This sunward bend electrified the experts instantly. Standard physics dictates that solar wind and radiation pressure should whip a comet's tail outward, away from our star's glare. Yet here, framed against Mars' rusty horizon from Tianwen-1's vantage, was a plume in outright rebellion, suggesting an active force at play, something emitting material with intent, not inertia. But the images revealed more than defiance. They unveiled elegance. A luminous halo of fine dust fluoresced around the core, like ethereal layers of light peeling from an onion of secrets. Chinese mission analysts, leveraging the orbiter's spectrometers originally tuned for Mars' atmospheric composition, clocked the jets at nearly 100 kilometers long. Far grander than models predicted for an object estimated at just 200 meters across its widest point. Cigar-shaped and tumbling end over end every 7.3 hours. These jets fanned out in symmetrical, rhythmic patterns, pulsing like synchronized breaths, rather than the chaotic spew of a melting ice ball. And the shocker that rippled through virtual conference halls? The nucleus showed zero fragmentation. No cracks, no shards, no debris cloud from months of observed outgassing back when Oumuamua zipped past Earth at 196,000 miles per hour in 2017. Despite the violence of its emissions, brightness surges, non-gravitational acceleration, and those heartbeat-like pulses, the body remained whole, solid, unbroken. Tianwen-1 had captured what astronomers had long suspected but dreaded confirming. Oumuamua isn't merely evaporating, it's acting. Coherent, resilient, almost deliberate in its endurance. As one ESA spectroscopist tweeted that night, "This isn't a comet dying, this is a survivor behaving." And with that, the floodgates of debate cracked wide open. For months leading up to this, scientists in the West had been piecing together a puzzle that refused to fit. Oumuamua's anomalies, documented exhaustively since its discovery by the Pan-STARRS 1 telescope in Hawaii, pushed it leagues beyond ordinary comet physics. Brightness fluctuations 10 times steeper than any solar system native, acceleration defying gravity alone, a non-gravitational boost of about 5 micrometers per second squared, jets angling impossibly toward the sun, and faint pulses mimicking a cosmic heartbeat, all screamed outlier. Skeptics waved it off. Miscalibrated scopes, overprocessed data, exaggerated hype. Ground-based giants like ESO's Very Large Telescope and Hubble had caught glimpses, but nothing conclusive. Then came the 2023 bombshell from UC Berkeley and Cornell. The acceleration could stem from trapped molecular hydrogen in water-rich ice, forged by cosmic rays over billions of years, sublimating invisibly under solar heat without the usual dusty tail. An elegant fix, turning Oumuamua into a planetesimal relic akin to our comets, but battered by interstellar wanderings. Yet doubts lingered. Why no detectable outgassing? Why the extreme elongation, 10 times longer than wide? Enter Tianwen-1's dataset, landing like a reality check amid NASA's post-shutdown scramble. The green tone? Verified, matching 2017 spectra but sharper, free of Earth's atmospheric interference. The stability? Crystal clear. No fragmentation, echoing the unbroken form that puzzled modelers. The plume's sunward curl? Unambiguous, captured from Mars' orbit where solar wind dynamics differ subtly from Earth's view. The long-range jets? Scaled in sequence, their 100-kilometer reach dwarfing expectations for a 200-meter body. And crucially, the vantage point, 30 million kilometers removed through a different atmosphere, sensors calibrated for Martian reds, not interstellar greens, yet the anomalies aligned perfectly. This wasn't coincidence or calibration error. It was triangulation, Earth, Mars, and the void agreeing on the impossible. Oumuamua's quirks aren't local artifacts. They're baked into its being. It flares when it shouldn't, far from solar fury. It thrusts without the debris drag of typical comets. It pulses with a 7.3-hour rhythm, hinting at internal rhythms, not random chaos. And now with Mars as witness, the debate doesn't collapse. It evolves. The strangeness is intrinsic, the implications? Seismic, forcing us to redraw the lines between comet and cosmic wildcard. Tianwen-1's camera, never meant for comet chasing, but a workhorse for Mars global scans, proved its mettle with tweaks that bordered on artistry. Precise exposure tweaks captured what Earth scopes only hinted at. Jet symmetry. Faint, multidirectional plumes erupted like miniature thrusters, firing in coordinated bursts. Some sunward, defying thermodynamics, others outward, as if balancing an unseen load. Water ice can't birth sunward jets without breaking energy laws. Sublimation demands heat from the star, pushing material away. Yet here they were, cycling every 6 hours, syncing with Oumuamua's tumble. This matched months of Earth observations, those heartbeat pulses from Hubble and Spitzer, but now etched in Martian light, they screamed structure. Not the wild frenzy of passive melt, but orchestrated venting, symmetrical arcs, predictable intervals, emissions that whispered of chambers or cavities regulating flow. Scientists squirmed at the word structured. Passive evaporation doesn't sculpt symmetry. It doesn't pulse with precision. It erodes, fragments, fades. But Oumuamua endures, jets firing like a system in equilibrium. The next question hangs heavy, unspoken in polite papers, but buzzing in late-night Slack channels. Is this nature's sleight of hand, or the echo of something engineered by forces we can't yet fathom? Layer on the spectroscopic punch, and the unease deepens. Tianwen-1's instruments, honed for Mars iron oxides and water vapor ghosts, sniffed out emission peaks laced with nickel and magnesium. Metals in comets, sure, but dominant here in ratios that defy norms. Nickel-heavy spectra echoed 2017 Earth readings, but from Mars's distance, unambiguous. These aren't bystanders. They're drivers, fueling the glow, perhaps forged in exotic formation cauldrons or scarred by eons of cosmic ray bombardment in the interstellar freeze. Combine that with symmetrical jets in that rogue plume, and minds race to cavities, hollows venting in non-random ways. Then the thermal kicker. Oumuamua's surface ran warmer than solar distance allowed, as if harboring internal fires or reacting to electromagnetic whispers no comet should hear. Internal heat? Exotic EM interplay? Neither sits easy. Both blur the natural-unnatural divide, echoing 2021's nitrogen ice hypothesis, a Pluto-like shard, eroded to elongation, or 2023's hydrogen trap model, yet amplifying their oddity. As one Chinese mission lead noted in a Xinhua briefing, this isn't just data, it's a mirror reflecting back questions we thought we'd answered about our place in the stars. NASA's original dread in 2017 wasn't peril. Oumuamua's path was a safe slingshot, peaking at 0.25 astronomical units from the Sun before hurtling toward Pegasus. No collision risk, no doomsday vibe. The fear was interpretive, that the quirks weren't flukes, that high-res Hubble shots, delayed now by 2025 shutdown chaos, would mirror ESA's hints and Indiscope's hunches. If an outsider like Tianwen-1 corroborated, NASA couldn't dodge the paradigm quake. And it did. Green sheen. intact core, pulsing rhythm, sun-defying plume, thrust sans shatter. Every flag confirmed. No more sensor noise alibis. Oumuamua dances to its own tune, and NASA's pending releases, freed post-November 12th, may unveil features we're emotionally unready for. The terror isn't invasion, it's invalidation. Models crumble, textbooks blush. China's gift? Accelerating the inevitable, a science reborn from the ashes of certainty. That fear? The instant an outsider's lens, from alien soil, strips away excuses. No noise, no hype, no error, just essence. Oumuamua's nature bucks rules. No melt model obedience, no stress shatter, no dust drag tails, no erratic exhale, no gravitational fidelity. China compelled acceptance of the uneasy, precision in a presumed primitive. Stunned silence grips labs not from threat, trajectories tame, but transformation. It's different, uncategorizable, model mangling. Astronomers morph to relic hunters, sifting stellar strata for analogs that mock them. What if this shard predates Earth by epochs, crust a codex from a dead system's dawn? Jets as final gasps, equilibriums echo through radiation storms we can't replicate, pulses not beacons but bellows, chambers ticking pressure like void veins? Or the query that chokes headlines, what if it's not expiring but executing? Protocols from progenitors predating Sol, designed from deep time rendering our natural, artificial split sophomoric. Comets crumble under such siege. This persists, ejects without exhaustion, glows without giveaway, accelerates absent aftermath, mirrors Marside as Earthside. Thus pre-perihelion, dual-world data converges. Oumuamua operates out. Structure resists ruin. Chemistry confounds canon. Emissions evoke the unspeakable. China didn't affirm oddity, they affirmed dread, that we're probing a misfit. Not tools falter, taxonomies do. Yet here's the spark. This misfit mirrors us. Interlopers like Oumuamua, now joined by 2I/Borisov, 2019's icy comet, and 3I/Atlas, July 2025's vapor-spewing speedster, perihelion October 29th at 1.36 astronomical units, eccentricity 6.14. Remind us the galaxy's a thoroughfare. Vera C. Rubin Observatory's 2025 kickoff, scanning skies thrice nightly, promises floods more. Each a snapshot of exoworlds, compositions, cataclysms, perhaps cradles of life. Oumuamua's quirks, thrust from hydrogen hideaways, nitrogen sculpt, teach resilience, rewriting exoplanet hunts. No peril but potential, clues to Pluto kin, dark matter drags, even biosignatures in alien ices. So would videos like this, spotlighting science's bleeding edge, prove meaningful, beneficial? Unequivocally, yes. They democratize wonder, bridging labs to living rooms, fostering global awe in an era of division. They inspire the next Rubin discoverer, fund the next Tianwen. They remind us, the universe doesn't whisper to elites, it shouts to seekers. Oumuamua fades, but its lesson lingers. Curiosity's our comet tail, propelling us sunward. Hit subscribe, share your theories below. What's Oumuamua to you, relic or riddle? Watch to the end, gaze up tonight. The stars are calling. Who answers?